Hi, this is my first video and this is my channel, Bike and Babble. And my first video is about Numpy. So, Numpy is one of those data science libraries. If someone wishes to break into this field and pursue a career in data science, they should start with Python and then start with this basic library called Numpy, followed by Pandas, Matplotlib, Seaborn, Scikit-learn, etc. Most of them are built based on this. So this library is used for basic data manipulation, storing and analyzing data. So let's start with NumPy. You should have it already installed in your computer. Pip install NumPy in your command line. And now when you run this first command in your Jupyter notebook import NumPy as NP. And so there are a lot of ways to generate NumPy arrays. Uh, I'll show the basic one is how do you convert a list into an array. Most of you are familiar with list. If you're familiar with Python, you know what a list is. For example, let's put my list is equal to 1, 2, 3, and no, no, sorry, 1, 2, 3. And when you put type of my list, you can see it's a list. So how do you convert this into an array? You put np dot. When you hit the tab, there are so many functions and classes and all. So we'll only cover the useful ones. Right? Np dot array, and you type my list. You can see this is how an array is created. So, but then the type is still list because we did not save this under any name. So let's save it as ARR, for example. And then when you write ARR, type ARR, now it's an array. So this is just one dimensional. I'll show you two dimensional also. For example, my matrix, a list under a list, 1, 2, 3, 4, 5, 6, open brackets, 7, 8, 9, and np.array, again, my matrix. You can see this is how you create a two-dimensional array. So I think this is the basic how you convert a list into an array. So I think most of you are familiar with range function in Python. There's one more similar to that. There's one more here. It's called as arrange. It's just 1R, not 2Rs. For any doubt, you can always click Shift Tab. So it helps if you have any doubt how to write this code. So you can see the start, stop, and step similar to Python range function. So stop is not included, stop number is not included, start, stops, and step is the step size. I'll show you with an example. If you want, for example, 0, 10, you can see 10 is not included. So if you want 10 to be included, you have to put as 11. The last number is not included always. So this is an array, and np.arrange is similar to Python range, and this is how we do this. If you know what is step, for example, if you want only even numbers, you put a step. So 0, this is skipped, 2 is displayed, 3 is skipped, 4 is displayed, 5 is skipped, 6 is displayed, 7 is skipped, 8 is displayed, 9 is skipped, and 10 is displayed. When you run this, you can see uh, all the even numbers are displayed and step size of 2. If you do this 0 to 101, you can see all of them are being displayed. You can do as 5 also, you can see, or you can also do as 50 also. So this is how step works. And other NumPy functions, like for example, if you want only zeros to be displayed, you can write np.zeros and you can write 10. You can see there are only floating point numbers being displayed. So if you want a two-dimensional, you can put, for example, 10, 5. Okay, you have to pass it under brackets. And you can see np.zeros, 10, 5, 10 rows and columns. First is the rows. So there are 10 rows and 5 is the columns. So it's always rows comma columns. You can also do once np dot once. You can put 5 once. All floating point numbers are displayed. So np dot once. Oh, sorry. And you can put 5 comma 5, 5 rows and 5 columns. So they're being displayed. And let me show you another one, which is identity matrix. So you can put np.i and you can put 5. You can see there's only one being displayed diagonally. You can also put as how much of a number. So identity matrix. You can see identity matrix is square matrix. And there's one more library called linspace. Similar. Don't get confused with the range. This is different, and you need to make sure that you don't include this e. It's actually linspace, not line space. Whenever you have doubt, you click on shift and tab, and you can see the information. Like you start, stop, and num. Let me explain you properly. You start with 0, and you want to end it with 100, or you want to end it with 10. And num, you can see shift tab, and there's something called num included. Here it's given as 50. You can put anything. So what this does is between 0 to 10, if I put 70, for example, between 0 to 10, 70 numbers are being displayed, evenly spaced. np.linspace, between 0 to 10, 70 numbers are evenly distributed. Let me give a simple example, 0 to 11, and let me say 10 numbers that are equally distributed. You can see everything is being included. Sorry, let me give an even more simple example. 0 to 10, let me put 11 numbers that is being evenly distributed. So you can see 0, 1, 2, 3 until 10. But what if you put 10? You can see between 0 to 10, 10 numbers are equally distributed. So which is why you're seeing it like this. So this is length space, and you can always check the length. Like for example, between 0 to 10, if you want, 0 to 1, if you want 55 numbers, you can see they're evenly distributed. What is the length? Open, just type len, and when you run, you can see there's 55 being displayed. And now let me show you how to generate random arrays. So just there's one function called np.random and rand. So when you click shift tab, you can give any number here. So it includes between 0 to 1, everything, any number will be displayed. So if you put 2, there'll be 2 numbers displayed. 1 is not included. So between 0 to 1, 1 is not included. For example, if you put 5, you can see random numbers being displayed. So each time you run the cell, different numbers will be displayed. You can see it can be anything, 2-dimensional also, 5, 7. You can see 5 rows and 7 columns. 2, 7 or 2, 3. Random numbers are being displayed. There's one more, np.random dot randn. So this will include negative numbers also. There's one thing here, when you run shift tab and when you scroll down, the distribution of mean and variance is 1. So when you write 5, for example, see there are negative numbers also being displayed. So each time you run, different set of numbers are being displayed. Now let me, there's one more library called np dot, not library, sorry, function called randint. Integers are being displayed. So when you put shift tab, there's low, there's high, and low is inclusive, high is exclusive, high is excluded, and the size. For example, between 0 to 100, if I need 5 random integers, you can see they are being displayed. You can put anything. 15 between 0 to 100. 15 random integers are being displayed. Each time you run, different numbers are being generated. So this is how random.rand int works. Random integers are returned. You can always do it. You can also have two-dimensional. For example, 4 comma 5. 4 rows and 5 columns are being displayed here now. So this is how you do it. You can also do it like to maybe just do things on your own. So if you count, you can see there are uh, 2 columns, 5 rows when you count, and there are four being displayed. You can keep increasing these numbers. Each time, different set of things are being displayed. So you can do this on your own, but I don't think this is more useful. 4 comma 5, this makes sense, right? Four columns, 4 rows and 5 columns. And one more thing I wish to say is about seed. For example, np.random.seed, and you give any number, for example 101, and now you generate some random integers like 0 to 10, give me 5 numbers, and you can see 16798 are being displayed. Now each time you run this alone in a new cell, newer numbers are being displayed. So if you want the same number to be displayed, that is 16798, each time you run this, you have to mention the seed. Seed can be any number. np.random.seed. So when you put np.random.seed and 101, you can see that the same number is being displayed. What if number was 55? For example, let's run this. 78575 is being displayed. Now let me do it again. Sorry. np.random.seed and same number 55 if I give, you can see 78575 is being displayed. So this is useful if you want the same set of numbers to be displayed. And one more thing, in this random integer, for example, between 0 to 100, if I need 15 numbers, and let me save it under something like, for example, a example, and a is being displayed. And if you want to find the largest, what you do is you write simple command a dot max. You can see 93 is being displayed. A dot min for the smallest, 0 is being displayed. You can see. And there's one more called a dot argmax, which returns the index position, which is 2. So 93 is in index position 2, 0, 1, 2. And a dot argmin 5. So 0 is in 5, 0, 1, 2, 3, 4, and 5. So this is how you do this. So these are basics. In the next video, I'll cover about, or next video, the next topic is about indexing and slicing, followed by some basic operations. Now let's learn about indexing and slicing. Or for example, np dot arrange and 0 to 11. So they're being displayed. 11 numbers are being displayed. And let me save it as ARR, for example. And ARR, when you run this, they're being displayed. Now, if you want the first 5 elements, ARR, and most of you are familiar with Python list, they know um, this how indexing and slicing works here. So if you want the first 5, you can do like this. So index position you mention. If you want the first number, you put as a dot 0. Oh, sorry, a is something else. Oh, sorry, ARR dot 0 or ARR. If you want everything to be displayed, you do it like this. If you want them to be in reverse, you do it like this. So indexing can be done here in NumPy arrays. And there's one thing you can do, and that is broadcasting. In list, you can't do in Python list, which is, for example, here are here are 0 to 5, for example. If you want to set it to 100, and when you run this ARR, you can see first 5 numbers are being they've changed into 100, and the rest of them are like this. So you can do this in NumPy arrays. And what else? I would like to show some operations that can be done in array. For example, ARR, when you run, let me do it again from first. Let me copy this. And when you run ARR, you can see they are being displayed. You can do some operations like ARR plus 4, for example. 4 is being added, ARR into ARR. You can perform all basic operations. You can, there's one tricky thing is when you divide, for example, since 0 is here, when you put ARR divided by ARR, for example, you can see there's something being displayed. So when you divide some number by 0, it is not a number, NaN is being displayed. So what if you divide it like this, 1 divided by ARR, so 1 divided by 0. You can see there's some warning displayed, zeros encountered, but the thing is there's something being displayed, infinity is being displayed. In normal Python, you can't do that. There'll be an error. But the thing with NumPy is that infinity will be displayed. And you can do a lot of things like in p dot square root, maybe. ARR, oh, sorry, square root or logarithmic something in p dot log. And I think there'll be negative infinity being displayed. Yes. So basic operations, all you can do in p dot sine, in p dot cos, sine, sorry. When you run, you can see everything is being displayed. And I want to say about this, for example, array.2d, and I create something like np dot range 0 to 25 maybe. And when I display this array.2d, it is being shown here. You can see 0 to 24. What if I reshape it to 5, 5? You can see they have been reshaped as 5 rows and 5 columns. You can't reshape it as 5 into 4 or 5 into 3. You know that because 5 into 4 is 20, it doesn't fit. Similarly, 5 into 3 also you can't do. I'll show you anyways. So 5 into 5 only works because 5 into 5 is 25. And let me save this again as an array 2D. And sorry, shift and enter array underscore 2D. Now, what if you want to find the sum? When you put a sum, all the elements are added and then they are displayed. Now, what if you want the sum of all the rows? All the rows will need to be displayed. So what you do, ARR underscore 2D dot sum. When you open brackets and put shift tab, axis will be displayed. So if you put as axis is equal to 0, okay, when you put axis is equal to 0, 15. So this downwards, they're being added. So 0 plus 5 plus 10 plus 15 plus 20 is 50. So similarly, if you put axis as 1, uh, as rows they are added, rows, and now here it's like columns, here it's like rows. So 1 plus 2 is 3, plus 3 6, plus 4 10. 10 is being displayed. So this is how sum works. If you want the whole sum, you just simply mention it as sum. If you want it as rows and columns, 0 1 and all you can mention. So that's it with NumPy. All the basics are covered.